Hello everyone, thank you for joining in today's lesson. I'm Teacher Purity. Welcome in today's lesson. So as you can see from the title, today we are dealing with the Longitudes grade 9 mathematics. And before we even solve any question, I want to give a summary of where we come up with the formula or the relation which we shall be using in these calculations. So in longitudes, we are dealing with the time, local time in different places, and we know that the Earth, for Earth to make a complete rotation, it rotates 360 degrees, and it takes 24 hours to rotate 360 degrees. So we have in 24 hours the Earth rotates 360 degrees. So in 1 hour, I want to know in 1 hour it will rotate how many, or it will have covered how many degrees. So in 1 hour, we multiply by 360 degrees, we divide by 24 hours, cancel, and we have 360 divided by 24, which gives us 15 degrees. So in 1 hour, the Earth rotation covers 15 degrees. So we also want to know in 1 degree is covered in how many, in how long. So we'll say if in 1 hour 15 degrees are covered, 1 hour is the same as 60 minutes. So in 60 minutes, we have 15 degrees. So we ask ourselves, 1 degree will be covered in how many minutes? So we'll have 1 degree times 60 minutes divided by 15 degrees, which gives us 4 minutes. A degree cancels degree, remain with minutes. So we therefore say that 1 degree is covered in 4 minutes. I'm very sure you have seen these before. So that is where it comes from. It's just a simple derivation or a summary of where we get 1 degree being equal to 4 minutes. It just means that the Earth rotates 1 degree in 4 minutes. So with that, we can go to our questions, which I was intending to solve them today. So we have a question here. As you can see, I'm using the textbook grade 9, and we'll be solving some of the questions in the textbook. Just pay attention. We have number 1, the revision exercise. Find the local time at a point on longitude 120 degrees when it is 8 a.m. at the prime meridian. So we can sketch the globe, the Earth's globe. For that, question 1, you can sketch the prime meridian is the same as the Greenwich meridian which is at the center of the earth, and this is the prime meridian. The prime meridian, and what we are supposed to know is that the prime meridian is always at 0 degrees. And then we can locate the other longitude, which we are told that it is at the west, 120 degrees west. So other students have a problem of locating west and east. Just the same as using the normal compass direction. We have north, south, east, and west. It is west of the Greenwich meridian. The Greenwich meridian is at the center. So this is the west, this is the east. So we'll have a sketch 120 degrees west longitude somewhere there, and this is 120 degrees west, just a sketch. So we are told that when it is 8 a.m. at the prime meridian, so the prime meridian is 8 a.m. So we are supposed to find the longitude difference between 0 degrees and 120 degrees. The longitude difference will be equal to, because at this point it is 0, we'll just have 120 degrees. Yes, that is the longitude difference. And then we can see how long the earth takes to rotate 120 degrees. So if 1 degree is covered in 4 minutes, 120 degrees would be covered in how many minutes? Cross multiplying, we'll have 120 degrees times 4 minutes divided by 1 degree. Degree cancels, and then we have 480 minutes. So we can convert those minutes to hours by dividing by 60, which is equal to 8 hours. 8 hours. Now going back to our question, we are finding the local time at a point on longitude 120 degrees west when it is 8 a.m. at the prime meridian. So at the prime meridian is already 8 a.m. 8 a.m. at the prime meridian. So we want to know the relation between 8 a.m. and the time at 120 degrees west of the prime meridian. So one thing you need to understand is that time is always ahead at the eastern part of when you are comparing points. This is because the sun rises from east and sets at west or in the west, and therefore time is always ahead at the eastern part. So comparing this 8 a.m. and the time at this point, we expect this 8 a.m. to be ahead because the prime meridian is eastern side of 120 degrees west. So at this time the sun was reached at this point before the point 120 degrees west, that longitude. So we'll have now that the 8 a.m. is ahead, we'll subtract 8 hours from 8 a.m. to see the time at that longitude. So 8 minus 8 hours will have 0000 hours, which can also be written as in 12-hour clock system, can be 12 midnight. Because remember, if at the prime meridian is 8 a.m., 8 in the morning, and the time at this point is behind, it means that it is not even yet in the morning, because it is behind with 8 hours. So it is still 12 and the midnight, but at the prime meridian it's already 8 a.m. Yeah, that's it about that first question. If you have any concern, comment there at the comment section and I will respond. So with that, we move to the next question, whereby I will not tackle question 2 because it's almost the same as question 1. It's just the same step. Let us look at question 3. Question 3. The time at longitude 65 degrees west is 10:30 a.m. Find the local time at a point on longitude 45 degrees west. So we can sketch try to analyze the question. We first locate the prime meridian so that you can come up with the other points, the other longitudes. So we have a longitude, both of them are at the west of the prime meridian. So these the first one is at 45 degrees west of the prime meridian. And then we have another longitude which is at 65 degrees west of the prime meridian. And then we are told that at this longitude it's 10:30 a.m. and then we are supposed to find the local time at a point the point of this longitude. So we have already derived the relation that we'll be using here. So before that, we need to know the longitude difference, the difference in degrees between this longitude and the other longitude. So what you're supposed to know is that because these two longitudes are the same side of the prime meridian, we subtract. And I stress the word subtract. When the points are the same side of the prime meridian, that is they are or at the west of the prime meridian or even at the east of the prime meridian, we subtract the longitudes. We subtract them. So the longitude difference will be equal to 65 degrees minus 45 degrees, which should give us 20 degrees. So we now want to know how long will the Earth take to rotate 20 degrees. If 1 degree is covered in 4 minutes, then 20 degrees will be covered in how many minutes? 20 degrees times 4 minutes, divide by 1 degree. Degree cancels. Then we have 20 times 4, which should give us 80 minutes. We can convert these minutes to hours by dividing by 60. And this should give us, let me use my calculator, 80 divided by 60 is giving me 1 hour 1/3, or 1/3 hours, which is the same as a third of an hour is 20 minutes. So 1 hour 20 minutes. So the earth will take 1 hour 20 minutes to rotate 20 degrees, or to cover 20 degrees. And therefore, let us go back to our question here. We need to know the time at this point. The time at this point. So again, we are here. Look at this. 65 degrees west and 45 degrees west. I need you to have a third eye to see this. 45 degrees west is at the eastern side, at the eastern side, or at the right hand side of 65 degrees west. And remember what we said initially? When a point is at the eastern side, then time is ahead, because remember the sun reached at that point before 65 degrees west, or the point which is at the western part. Don't get confused, where is east coming from? And we have west and west. I'm saying that 45 degrees west is at the eastern part, the eastern side. The sun will first reach at this longitude before this longitude. So if it's 10:30 a.m. here, so it means 10:30 a.m. reached at 45 degrees west 1 hour 20 minutes ago. So what is the time now at 45 degrees west? So what are we supposed to do? We are supposed to add 1 hour 20 minutes to 10:30 a.m. So we'll have 10:30 plus 1 hour 20 minutes. This is 0511. So at 45 degrees west, the time is 11:50 a.m. So that is it about that question. I want to look at question 5. Look at question 5. I won't do question 4, because as you can see, as I mentioned earlier, question 4 we have 45 degrees east and 125 degrees east. So those are points at the same side of the Greenwich meridian. So I will just do the same way as we have done in question 3. We are going to subtract the longitudes for us to get the longitude difference, because they are on the same side of the Greenwich or the prime meridian. So let us do number 5 for this case. What would be the local time at a point on longitude 75 degrees east when the time at a point on longitude 65 degrees west is 10 a.m.? So as I said, the trick, just draw a sketch of the globe and it will help you more to identify or to analyze your question. So let us draw the globe. Let me choose a different paper. Come up with a globe. Locate the prime meridian first. We already know it is 0 degrees, not east, not west, because we relate east or west with reference to the prime meridian. So what would be the local time on longitude 75 degrees east? 75 degrees east. Where 75 degrees east? Sketch, this is just a sketch. And then we have another longitude 65 degrees west of the green meridian, of the prime meridian, and then we have a time at the longitude 65 degrees west is 10 a.m. So the time here is 10 a.m. I said the first step is to find the longitude difference. Longitude difference. Now look at this. This is 75 degrees east of the prime meridian and 65 degrees west of the prime meridian. So the 2 points or the 2 longitudes are the different sides of the prime meridian. So the keyword here is, or the key sentence here is, when the points are at opposite sides, the different sides of the prime meridian, then we add the longitudes to come up with the longitude difference. Because remember, we already have 75 degrees here and we have another 65 degrees. So we'll take the 65 degrees plus the 75 degrees. So this is 65 degrees plus 75 degrees. Let us confirm that. 65 plus 75 should give us 140 degrees. So 140 degrees should be covered in how many minutes? Let's see. 1 degree is covered in 4 minutes. So 140 degrees is covered in how many minutes? We cross multiply, we divide. 4 minutes. Divide by 1 degree. Degree cancels degree. And this is 140 times 4 is giving me 560 degrees. Minutes. Remember, degrees has cancelled with degrees and remain with minutes because we were checking how many minutes taken to cover 140 degrees. So we divide by 60 to convert these to hours. Divide by 60. We'll have 1/3 hours, which is equivalent to 9 hours 20 minutes. And then let us go back to our question. We want to know the time, the local time at a point on longitude 75 degrees east. So we want to know the time at this longitude when the time at this longitude is 10 a.m. Remember, as we said earlier, when the point is at the eastern part of the longitude, which we already given the time, then the time at this point is ahead. The sun reached at this point before this point. So if it's 10 a.m. already at this point, it means that 10 a.m. at this point reached 9 hours 20 minutes ago. right? So we are supposed to take 10 a.m. plus 9 hours 20 minutes so that we can know the time at the longitude 75 degrees east. So we'll have 10 a.m. plus 9 hours 20 minutes. This is 20 19, so this is 1920 hours. Now you can also convert these into 12-hour clock system or so on, because the question is not restricting us to that point. We can leave it at that point. And then thank you very much for watching this lesson. Make sure you continue watching my lessons, and if you found this video helpful to you, kindly subscribe to my YouTube channel for more lessons. Thank you very much for watching. Till next time, bye bye.